morning, everyone. We're the researchers of Blind Chest Trap Sensor. Project leader is Abkina, and the co-researchers is Tumaging, Gagnan, Hapos, and Meneses. The introduction and background of the study. So the purpose of this one is to develop a more usable tool for blind people. Second is it improves the navigation of objects. Third is it is capable for guiding blind people. Then lastly, it is more usable compared to blind stick.
For the statement of the problem, this design emphasizes the blind chest strap sensor is capable for guiding blind and elderly people. For the development of this design, the researchers addressed the following questions. First is, what design parameters should the researchers consider to develop a blind chest strap sensor? Second, what development and implementation strategy should the researchers adopt to be utilized to ensure that the blind chest strap sensor will work? And last, the third one is, what evaluation parameters should the researchers assess in order to measure the performance and acceptability of blind chest strap sensor? The objectives of the study is to aim, or the aim of this study is to produce a blind chest strap sensor that are effective and capable to guide blind people and elderly people. The researchers also want to create a more useful tool that could improve the navigation of objects for blind people. Here are the specific objectives of the study. First, to design a more usable and effective blind chest strap sensor. Second, to develop a blind chest strap sensor with the necessary materials to live in a safer and responsive environment. Third, to evaluate a blind chest strap sensor in terms of its capability, safety, and efficiency. The significance of the study. This study develops a blind chest strap sensor to improve the safety of the blind people when they walk in homes and in streets. It is also applicable to elderly people who have difficulty of vision and to people who lost their vision due to accidents. Blind chest strap sensor is much better to use compared to a regular blind stick alone because it has built-in ultrasonic sensors that would detect nearby objects.
Conceptual framework. In the input category, the researchers put the baseline research. Second is the information or interviews coming from blind people. In the process category, the researchers put the system design. Second is development. And lastly is implementation. All these processes result the output, which is the blind chest strap sensor. Scope and limitations. The focus of this blind chest strap sensor is only to detect close objects. If the blind person is walking near the walls or in any close objects, the ultrasonic sensor will automatically detect and the DC buzzer will make a sound to inform the blind person. This ultrasonic sensor is surely placed in the front of the chest strap so that it can give the potential of guiding the subject.
So in our next topic is review of related literature. So the first one is design and implementation of a white cane based on a vibration distance sensing technique for blind people. So in this work, the sensing method is based on a relation distance or vibration. The closer the object, the faster its vibration magnitude. Then the next one is blind belt using ultrasonic sensor. So in this project, it uses 3 ultrasonic sensors attached to the front, left, and right areas of the belt. So whenever the object is detected near any of these areas, the buzzer will be ringing.
Then the third one is low-cost ultrasonic smart glasses for blind. This device includes a pair of glasses and an obstacle detection module fitted in it in the center. Then the fourth one is ultrasonic navigation-based blind aid for the visually impaired. Ultrasonic navigation-based blind aid is built to guide the visually impaired and blind to walk easily in urban areas. And the third one is low-cost ultrasonic smart glasses for blind. This device includes a pair of glasses and an obstacle detection module fitted in the center. Then the fourth one is ultrasonic navigation-based blind aid for the visually impaired. Ultrasonic navigation-based blind aid is built to guide the visually impaired and blind to walk easily in urban areas.
Methodology. The first is design. The researchers will use the ultrasonic sensors, Arduino Uno, battery, and etc. Development. The researchers will discuss each processes of making blind chest strap sensor. Implementation. The researchers will discuss the steps on how to use blind chest strap sensor. For the evaluation, the researchers will base the efficiency with the number of trials and will be rated using Likert scale. For the design, and this is the design that we use in our blind chest strap sensor. The next is the exploded view. This is the exploded view of our blind chest strap sensor.
Development. Conceptual design of blind chest strap, divided into three main sections. First is the measuring stage where the HC-R04 is located, or the ultrasonic sensor for distance measuring. Second is reading stage where the microprocessor or Arduino is located for reading inputs. And lastly, the signaling stage. Piezo buzzer is located for basic beeps and tones. This is the 3D pictorial diagram of blind strap where all the components are connected.
Implementation. For implementing the design, the first step is to put 9-volt battery on the battery connector. Second is to turn on the switch. Third is to check the ultrasonic sensor's functionality by placing a hand in front of the sensor. Then fourth is to wear blind chest strap sensor. After wearing and checking the blind chest strap sensor, the blind person can now start to walk.
Evaluation. For the evaluation, the researcher will base the efficiency by the number of trials and will be rated using Likert scale. The testing will be conducted by the measuring the levels of the sound of the buzzer and the distance of the object. If the sensor starts to detect an object on a specific distance, the buzzer will beep very slow. And if the blind person is moving closer to the object, the sound of the buzzer will beep rapidly.